In addition to finishing section 9.2, we're also moving into one concept from 9.3. It's the law of sines. You should have been exposed to it in your geometry course. We're going to use the law of sines to work with non-right triangles. If you have a right triangle, you should work with the basic sine, cosine, and tangent ratios. You really only want to use the law of sines when you have a non-right triangle. And you can only use it in certain scenarios. So just as a reminder, generic triangle, ABC, and then the opposite side lengths are little a, opposite angle A, little b, opposite angle B, little c, opposite angle C. The law of sines, this is more of a proportion, and it reads sine of angle A divided by opposite side length A equals sine of angle B divided by opposite side length B, which equals sine of angle C divided by opposite side length C. So when you're working with this law of sines formula, you're really only going to use two parts of the equation, either sine of A over A equals sine B over B, or you're going to use sine A over A equals sine C over C, or you'll use sine B over B equals sine C over C. You'll never use all three at the same time. And remember, the triangles don't always have to be named ABC. It could be triangle XYZ or PQR. Some textbooks will often write the law of sines written as the reciprocal of the proportion we have here. So if you see it this way, it's basically the same thing. You're just using it to solve the triangle, which means find all missing sides and angle measures. Now, when you're working with the law of sines, there are some unique cases, and you want to be careful when you pull the law of sines out. So there's some special safe cases that you can always use the law of sines, and then after our midterm, we'll come back and look at the cases where you should not use the law of sines, or you have to be careful about using the law of sines. So the first case would be the angle side angle scenario. That's where you have two angles and a side in between the two angle measures. And then the second case would be the angle side scenario. That's where you have two angles followed by a side. Both cases here, you have two angles provided to you. And these are safe cases to use the law of sines. Anything else, you would want to stay away from law of sines until you learn about the other unique cases. So our first example here measures or gives an angle of 32 degrees, an angle of 68 degrees, and an angle or a side length of 23 centimeters. So here we have two angles and a side length given, and we need to find side lengths B and C. So first, what we want to do is sketch ourselves a triangle and label it appropriately. So I have triangle ABC here with the given angle measures and the side opposite angle A here. And now I need to look at, is this a safe case to use? So I have an angle, and a side scenario here. So that's a safe case, angle, side. And when you set this up, you always want to set up the law of sines with an angle and an opposite side length. If you don't even have that scenario, you can't even use the law of sines. So the way we're going to work this is we're going to use the law of sines with sine of A over opposite side length equals sine of B over opposite side length. And we're going to end up solving this proportion here for B. So not sure what just happened here. So we're going to populate our proportion, law of sines proportion here. And at this point, the recommendation is to solve for B, and in order to do so, we should cross multiply and then isolate angle or side length B once we finish cross multiplying. So after I cross multiply, I have B times the sine of 32 equals 23 times the sine of 68 degrees. And we're going to divide both sides by sine 32 to isolate B. This is your exact side length for the sine, or for side length B here in centimeters. We're going to need to approximate it to use this value as we move forward in many cases. But when we approximate it, we get 40.24 centimeters. So that's our side length B here. Now I need to find side length C. Since I have two angles, I can easily find my third angle because all three angles of a triangle always sum to 180 degrees. So that gives me angle C is 80. And then I can use a similar strategy, law of sines, to find side length C. When possible, always use given information instead of using, so in this case, I would prefer to use 32 degrees and 23 centimeters instead of 68 degrees and the value we just found for B. And that's because if we made a mistake finding B, then C is automatically incorrect. So in this case, again, sine of 32 over 23 centimeters is going to equal sine of 80 degrees over side length C here. Once I set it up, again, to solve for C, we're going to cross multiply. So I have C equals sine 32 degrees equals 23 sine 80 degrees. And I'm going to divide both sides by the sine of 32 degrees here. And I'm going to isolate C. This is my exact value in centimeters for the side length C. And then my approximate value here is 42.74 centimeters.